It is permissible to run low-voltage wiring and pneumatic tubing in the same conduit, provided certain conditions outlined in the National Electrical Code are met. Specifically, NEC Section 300.3 Code addresses this scenario. It's important to understand the requirements to ensure a safe and compliant installation. Firstly, the conduit itself must be listed and approved for both electrical and pneumatic applications. This means the conduit material and construction are designed to withstand the potential hazards associated with both electricity and compressed air. Secondly, a physical barrier must separate the low-voltage wiring and the pneumatic tubing within the conduit. This barrier prevents direct contact between the electrical conductors and the pneumatic system, minimizing the risk of electrical shock or damage to the tubing. The barrier can be a divider or separator specifically designed for this purpose and listed for use within the conduit. Thirdly, the conduit must have sufficient internal space to accommodate both the wiring and tubing without overcrowding. Overcrowding can lead to insulation damage on the wires, restricted airflow in the tubing, and difficulty in future maintenance or modifications. The conduit fill calculations specified in the NEC must be followed to ensure adequate space. Fourthly, the conduit must be properly sealed to prevent the mixing of air and electrical components. This is especially important if the pneumatic system uses lubricated air, as the oil can degrade the wire insulation and create a fire hazard. Proper sealing also prevents moisture from entering the conduit, which can corrode the electrical connections. In addition to these specific conditions, there are several additional considerations to keep in mind. Firstly, it is generally recommended to use separate conduits for low-voltage wiring and pneumatic tubing whenever possible. This simplifies maintenance and troubleshooting, as it allows you to isolate and work on either the electrical or pneumatic system without affecting the other. Secondly, if the low-voltage wiring is carrying Class 1 or Class 2 circuits, additional requirements may apply. For example, the NEC may require the use of a metallic conduit to provide better grounding and shielding for these circuits. Class 1 circuits are power-limited circuits with a higher voltage and current than Class 2 circuits. Class 2 circuits are considered safer due to their lower power levels. Always refer to the specific requirements in the NEC for Class 1 and Class 2 circuits. Thirdly, it is crucial to consult with a qualified electrician and refer to the latest edition of the NEC for specific requirements and any applicable exceptions. Electrical codes can be complex and vary depending on the jurisdiction. A qualified electrician can ensure that the installation meets all applicable requirements and is safe for its intended use. Let's delve deeper into each of these aspects, starting with the listing requirements for the conduit. When selecting a conduit for combined electrical and pneumatic use, it is essential to verify that it is listed by a recognized testing laboratory such as Underwriters Laboratories or Intertech. The listing mark on the conduit indicates that it has been tested and found to meet the applicable safety standards for both electrical and pneumatic applications. The listing will specify the types of wiring and tubing that are approved for use with the conduit, as well as any limitations in size or type of installation. Next, let's examine the requirements for the physical barrier separating the wiring and tubing. The barrier must be made of a non-conductive material that is suitable for the environment in which the conduit is installed. It must be securely fastened within the conduit to prevent it from shifting or dislodging. The barrier should also be designed to provide adequate separation between the wiring and tubing to prevent any accidental contact. In addition to the physical barrier, it is also important to consider the insulation rating of the wiring used in the conduit. The wiring should have an insulation rating that is appropriate for the voltage and temperature of the application. It should also be resistant to moisture, chemicals, and other environmental factors that may be present in the conduit. Now let's discuss the importance of proper conduit fill. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by wires and cables. This percentage varies depending on the type of conduit, the number of wires, and the size of the wires. When calculating the conduit fill for a combined electrical and pneumatic installation, you must take into account the space occupied by both the wiring and the tubing. If the conduit is overcrowded, it can be difficult to pull the wires and tubing through the conduit, and it can also increase the risk of damage to the insulation. In addition to the conduit fill requirements, it is also important to consider the bending radius of the conduit. The NEC specifies the minimum bending radius for different types of conduit. If the conduit is bent too sharply, it can damage the conduit or the wires and tubing inside. Finally, let's address the importance of proper sealing of the conduit. The conduit should be sealed at all entry and exit points to prevent the ingress of moisture, dust, and other contaminants. The sealing should be done with a sealant that is compatible with the conduit material and the wiring and tubing being used. In addition to sealing the conduit, it is also important to ensure that the connections to the electrical and pneumatic equipment are properly sealed. This will prevent leakage of air or other fluids from the pneumatic system, and it will also protect the electrical connections from corrosion. In summary, while it is permissible to run low-voltage wiring and pneumatic tubing in the same conduit under the NEC, it is crucial to adhere to specific conditions. These conditions include using a listed conduit for both applications, incorporating a physical barrier between the wiring and tubing, ensuring adequate conduit fill, and properly sealing the conduit. Furthermore, it is generally recommended to use separate conduits for ease of maintenance and troubleshooting. Always consult the latest edition of the NEC and a qualified electrician to ensure a safe and code-compliant installation. For those involved in electrical work, understanding the nuances of the NEC is paramount. The code provides a comprehensive set of guidelines for electrical installations aimed at ensuring safety and preventing hazards. Familiarizing yourself with the relevant sections of the NEC, such as Section 300.3 in this case, is essential for compliance and safe practices. Remember that electrical codes are constantly evolving to reflect advancements in technology and to address emerging safety concerns. Staying updated with the latest edition of the NEC is therefore crucial for electrical professionals. Moreover, practical experience and training are invaluable in applying the NEC effectively. While the code provides a framework for electrical installations, it is often necessary to interpret and adapt the requirements to specific situations. This requires a thorough understanding of electrical principles and best practices. Consulting with experienced electricians or electrical engineers can provide valuable insights and guidance in complex installations. In addition to the NEC, other standards and regulations may also apply to electrical installations depending on the location and type of application. These may include local building codes, industry standards, and manufacturer's specifications. It is important to be aware of all applicable requirements and to ensure that the installation complies with all of them. Electrical safety should always be the top priority in any electrical work. Electricity can be dangerous, and even a small mistake can have serious consequences. By following the NEC and other applicable standards, and by exercising caution and common sense, you can minimize the risk of electrical accidents. Before starting any electrical work, it is essential to de-energize the circuit and verify that it is de-energized with a voltage tester. Always use appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical equipment when you are tired or distracted. If you are not comfortable working on electrical equipment, it is best to hire a qualified electrician to do the work for you. Electricity is a powerful force, and it should be treated with respect. By following these safety precautions, you can help to protect yourself and others from electrical hazards. Let's also consider some practical examples to illustrate the application of these principles. Imagine you are installing a low-voltage control system for a pneumatic actuator in a manufacturing facility. The control system uses 24 volts DC to operate the actuator, and the pneumatic tubing supplies compressed air to the actuator. In this scenario, you could potentially run the low-voltage wiring and the pneumatic tubing in the same conduit, provided you meet the requirements of NEC Section 300.3. You would need to use a conduit that is listed for both electrical and pneumatic applications, and you would need to install a physical barrier between the wiring and the tubing. You would also need to ensure that the conduit has sufficient internal space to accommodate both the wiring and tubing without overcrowding. And you would need to properly seal the conduit to prevent the mixing of air and electrical components. Alternatively, you could choose to run the wiring and tubing in separate conduits. This would simplify maintenance and troubleshooting, as it would allow you to isolate and work on either the electrical or pneumatic system without affecting the other. It would also eliminate the need for a physical barrier between the wiring and tubing. Ultimately, the decision of whether to run the wiring and tubing in the same conduit or in separate conduits depends on the specific circumstances of the installation. Factors to consider include the cost of materials and labor, the ease of maintenance and troubleshooting, and the potential for future modifications. Another example could be a residential smart home installation. In this case, you might have low voltage wiring for lighting control and pneumatic tubing for a central vacuum system. Again, the NEC allows for the possibility of running these together in a conduit, but strict adherence to the listed requirements is crucial. The choice depends on factors like aesthetics, ease of installation, and future upgrade considerations. Finally, remember that the NEC is not a substitute for good engineering judgment. It is a set of minimum requirements, and in some cases, it may be necessary to exceed those requirements to ensure a safe and reliable installation. Always use your best judgment and consult with a qualified electrician or electrical engineer if you have any questions or concerns. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician and refer to the latest edition of the NEC for specific requirements and any applicable exceptions. Understanding the NEC and applying it correctly is essential for ensuring electrical safety and preventing hazards. The NEC is a complex document, but by studying it carefully and seeking guidance from experienced professionals, you can master its principles and apply them effectively in your work. Always remember that electrical safety is paramount, and that following the NEC is the best way to protect yourself and others from electrical hazards. This detailed explanation should provide a comprehensive understanding of the NEC requirements for running low-voltage wiring and pneumatic tubing in the same conduit. Always prioritize safety and consult with qualified professionals to ensure code compliance.